What if I told you that General Motors spent over $1 billion developing an engine that would become the most despised power plant in American automotive history? An engine so advanced, it featured 32 valves, dual overhead cams, and could run 50 miles without any coolant whatsoever. An engine that powered Cadillacs from the White House to the Indy 500. This is the story of the Northstar V8, the technological marvel that became a mechanical nightmare. Picture this. It's 1992 and you're walking into a Cadillac showroom. The salesman's eyes light up as he pops the hood of a gleaming Seville STS. This, he says with reverence, is the future of American luxury. Under that hood sits a jewel-like aluminum V8. Its magnesium cam covers emblazoned with 32-valve Northstar. It looks more like something from a Ferrari than Detroit. The specs are intoxicating: 295 horsepower from just 4.6 liters, 4 valves per cylinder, dual overhead cams, all aluminum construction. In an era when most American V8s were still pushrod dinosaurs making maybe 200 horsepower from 5.7 liters, this was revolutionary. The Northstar wasn't just another engine. It was Cadillac's declaration of war against Mercedes, BMW, and Lexus. After watching the Germans and Japanese eat their lunch throughout the 1980s, General Motors decided to fight back with the most technologically advanced V8 ever built in America. They succeeded. What they didn't know was that they'd also created a time bomb that would destroy engines, drain bank accounts, and turn the name Northstar into a punchline for automotive suffering. To understand how Cadillac created this disaster, we need to travel back to 1985. Cadillac was bleeding customers. Their average buyer age had climbed to 62. Younger luxury buyers wouldn't even consider an American car. The Cimarron, Cadillac's attempt at a compact luxury car, had become the laughingstock of the industry. It was literally a Chevrolet Cavalier with leather seats and a hood ornament, priced at twice the cost. Meanwhile, BMW was selling 3 Series sedans as fast as they could import them. Mercedes dominated the high-end market, and then Lexus arrived in 1989 with the LS 400, a car so refined that Mercedes allegedly bought several just to figure out how Toyota did it. Roger Smith, GM's CEO, was furious. He ordered Cadillac to develop an engine that would humiliate the imports. Money was no object. The best engineers in Detroit were assigned to the project. The development team benchmarked everything: BMW's silky inline 6s, Mercedes bulletproof V8s, Ferrari's high-revving V8s. They wanted to combine the best of all worlds. The project name was L47 internally, but marketing had a better idea: Northstar. Like the navigation star that guides travelers, this engine would guide Cadillac back to greatness. The engineering team, led by John Joannis, set impossible targets. The engine had to rev to 6,500 RPM. Unheard of for an American V8. It needed to be smoother than a BMW, more powerful than Mercedes, and more reliable than Lexus. It would use technology never before seen in a mass-production American engine. The block and heads would be cast from aluminum using a precision lost foam process. The crankshaft would be forged steel, cross-drilled for perfect oil flow. 4 chain-driven camshaft would operate 32 valves through direct-acting hydraulic lifters. No rocker arms, no push rods, just pure efficiency. Here's where things got interesting. The Northstar featured something called the limp home mode, officially termed the powertrain control module overheat protection mode. If the engine lost coolant, it would automatically shut down fuel to alternating cylinders, using them as air pumps to cool the engine. In theory, you could drive 50 miles with no coolant at all. GM's marketing department loved this. They filmed commercials showing Northstar-powered Cadillacs crossing Death Valley with punctured radiators. What could possibly go wrong? The first Northstar engines rolled off the assembly line at GM's Livonia engine plant in 1992. The initial 4.6-liter version produced 295 horsepower and 290 lb-ft of torque. Compression ratio was 10.3.1. The engine breathed through a specially tuned intake manifold with equal-length runners for each cylinder. The exhaust system featured dual catalytic converters and resonators tuned to produce what Cadillac called a sophisticated growl. The whole package weighed just 445 pounds, about 200 pounds lighter than the old 4.9-liter pushrod V8 it replaced. The automotive press went wild. Motor Trend called it the most advanced production V8 in the world. Car and driver measured 0-60 in 7.1 seconds in a 4,200-pound Seville STS, faster than a BMW 540i. The engine was smooth, powerful, and technologically impressive. Cadillac finally had a weapon to fight the imports. Orders poured in. For the 1993 model year, every Northstar-equipped Cadillac sold before it even reached the showroom, but problems emerged almost immediately. The first issue owners noticed was oil consumption. Northstar engines burned through a quart of oil every 800, 1,000 miles. GM claimed this was normal for a high-performance engine. Owners disagreed. Then came the oil leaks. The external oil manifold, a complex aluminum casting that distributed oil to the cylinder heads, would develop cracks. The repair required removing the intake manifold and cost $1,500. Those were just appetizers. The main course of disaster was head gasket failure. The Northstar's aluminum block and heads expanded at different rates when heated. GM had used special head bolts with a unique thread pitch, 11 more x 1.5, designed to handle the thermal stress. They couldn't. The threads in the aluminum block would strip out, causing the head bolts to lose clamping force. Coolant would leak into the combustion chambers. The engine would overheat. Game over. The repair was nightmarish. You couldn't just replace the head gaskets. The stripped threads meant the block needed to be repaired with steel thread inserts, a process called time certs or norms inserts, depending on the kit used. The engine had to come out, the heads had to come off. Each bolt hole had to be drilled, tapped, and fitted with a steel insert. The labor alone ran $3,000, $4,000. Total repair bills often exceeded $5,000. On cars worth maybe $8,000. But wait, there's more. The Northstar's sophisticated variable valve timing system, which adjusted cam timing for optimal power and efficiency, had its own problems. The VVT solenoids would clog with sludge if owners didn't change oil religiously every 3,000 miles. When they failed, the engine would run rough and throw codes. Replacement required removing the front cover and timing chains, another $2,000 repair. The carbon buildup was spectacular. The Northstar's combustion chambers were prone to accumulating carbon deposits that would cause pre-ignition and detonation. GM's solution: they programmed the engine computer to slightly retard timing and richen the mixture when it detected knock. This masked the problem, but killed fuel economy and performance. Some engines required complete disassembly for carbon cleaning after just 60,000 miles. The crankshaft position sensor was another weak point. Mounted at the front of the engine where it was exposed to extreme heat, it would fail without warning, leaving drivers stranded. The repair wasn't expensive, maybe $200, but the sensor failed so often that some owners carried spares in their glove boxes. Let's talk about the infamous limp home mode that GM bragged about. Yes, the engine could theoretically run without coolant by shutting down cylinders. What GM didn't mention was that doing so would destroy the catalytic converters, warp the heads, and potentially crack the block. Several owners discovered this after trying to limp home from minor coolant leaks, turning $300 radiator repairs into $8,000 engine replacements. By 2000, the Northstar's reputation was radioactive. Internet forums were filled with horror stories. One owner documented spending $12,000 on repairs for a car he'd bought for $10,000. Another went through 3 engines in 100,000 miles. Mechanics started refusing to work on Northstar-equipped cars. Some dealers would actually try to talk customers out of buying them. GM kept insisting there was no problem. They issued technical service bulletins for the head gasket issues, but never admitted to a design flaw. They blamed owners for not maintaining their vehicles properly. They even created an improved head bolt design in 2000, essentially admitting the original design was flawed while claiming everything was fine. The 4.6-liter wasn't the only variant. GM created a 4.4-liter supercharged version for the STS-V and XLR-V, making 469 horsepower. They developed a 4.0-liter version, making 275 horsepower. There was even a 3.5-liter variant for the Chinese market. Every single version had head gasket problems. The supercharged engines were even worse. The additional heat and pressure accelerated bolt failure. The racing versions tell a different story. The Northstar LMP engine, developed for Le Mans prototype racing, was actually brilliant, displacing 4.0 liters and making over 650 horsepower. It powered Cadillac to multiple American Le Mans Series victories. The secret: race teams replaced the head bolts after every race and used special gaskets designed for extreme temperatures. They essentially rebuilt the top end every few thousand miles. Not exactly practical for street use. The Northstar's influence on other GM engines was significant but controversial. The lessons learned from its development influenced the LS series of V8s, specifically what not to do. The LS engines used iron blocks, conventional head bolts, and simpler valve trains. They made similar power with far better reliability. It's telling that the LS series became one of the most successful engine families in history, while the Northstar became a cautionary tale. From an engineering perspective, the Northstar's failure was fascinating. The precision loss foam casting process GM used for the block was revolutionary, but created porosity issues. The aluminum alloy specification was optimized for weight and heat dissipation, but not for thread strength. The head bolt design used a special thread pitch that increased clamping force but concentrated stress in a smaller area. Every advanced feature that made the Northstar impressive on paper made it fragile in reality. The financial impact on owners was devastating. Consider a typical scenario. Someone buys a 2002 DeVille for $8,000 with 80,000 miles. At 95,000 miles, the head gaskets fail. The repair quote is $4,500. The car is worth maybe $5,000 fixed. Many owners simply scrapped their cars. Thousands of otherwise excellent Cadillacs went to junkyards with blown head gaskets, their leather-wrapped interiors and sophisticated suspensions made worthless by an unrepairable engine. The human cost went beyond money. The Northstar killed Cadillac's reputation with an entire generation of buyers. People who'd stretched their budgets to buy a used Cadillac, believing in American luxury, were betrayed by catastrophic repair bills. These weren't neglectful owners. Many had complete service records showing perfect maintenance. The engine failed anyway. GM finally admitted defeat in 2011, discontinuing the Northstar after 19 years of production. The final versions used in the DTS and STS had received numerous updates, including stronger head bolts, improved head gasket design, and better oil management. They were significantly more reliable, but still couldn't shake the Northstar's toxic reputation. The damage was done. The replacement was telling. The new Cadillac engines were developments of the corporate GM small block architecture, simpler, proven designs without the Northstar's exotic technology. The 3.6-liter high-feature V6 and later turbocharged 4 cylinders delivered similar performance with vastly superior reliability. Cadillac learned that American buyers valued dependability over specification sheets. So what was actually going wrong at the molecular level? The head bolt failures were caused by a phenomenon called stress corrosion cracking. The combination of mechanical stress, heat cycling, and coolant chemistry created micro cracks in the aluminum threads. These cracks propagated over thousands of heat cycles until the threads completely failed. The time-cert repair worked because the steel inserts were immune to this type of failure. The oil consumption issue stemmed from the ring pack design. The Northstar used low-tension piston rings to reduce friction and improve fuel economy, combined with the engine's high operating temperatures and long oil change intervals that GM recommended, up to 10,000 miles with their oil life monitor system. The rings would lose tension and allow oil to enter the combustion chambers. Once consumption started, it accelerated rapidly. Here's the kicker. GM engineers knew about many of these issues during development. Internal documents released during bankruptcy proceedings showed that prototype engines experienced head gasket failures, During durability testing, the solution was deemed too expensive. It would have required redesigning the block with stronger alloy and larger head bolts. Management decided the current design was acceptable and pushed production forward. The Northstar wasn't just a failed engine. It was a symbol of everything wrong with General Motors in the 1990s and 2000s. Ambitious engineering undermined by cost-cutting. Revolutionary technology rushed to market without adequate testing. Corporate arrogance that blamed customers for design flaws. The same company that created the legendarily reliable small block V8 had somehow built an engine that self-destructed at 100,000 miles. Today, Northstar-equipped Cadillacs are virtually worthless. A clean 2005 DeVille that sold for $52,000 new might fetch $3,000 if the engine hasn't blown. Many sellers don't even mention head gasket repairs in their ads because it's assumed any Northstar has either had them done or needs them. Mechanics joke about Northstar special and beautiful Cadillacs for sale cheap because the owner got a repair quote. The aftermarket has developed extensive solutions. Companies like Northstar Performance sell complete head stud kits, upgraded head gaskets, and even billet aluminum blocks for those crazy enough to build a bulletproof Northstar. The repairs can make the engine reliable, but at a cost exceeding the value of most cars they came in. It's like putting a $15,000 heart transplant in a $5,000 patient. The tragedy is that the Northstar was brilliant in so many ways. The power delivery was smooth and linear. The engine note was sophisticated, a gentle growl that became a snarl. At full throttle, the technology was genuinely advanced. In a parallel universe where GM solved the head bolt issue during development, the Northstar might have become legendary for the right reasons. Some perspective. Mercedes had their own disasters, with the early M272 and M273 engines' balance shaft issues. BMW's N54 suffered from failing fuel pumps and wastegate rattle. Audi's timing chain tensioners were ticking time bombs. The difference was that these companies generally stood behind their products with extended warranties and recall campaigns. GM let Northstar owners twist in the wind. The cultural impact extended beyond Cadillac. The Northstar failure contributed to GM's bankruptcy in 2009. It was cited in congressional hearings as an example of the company's dysfunction. Auto journalists used it as shorthand for Detroit's inability to compete with imports. Every head gasket failure was another nail in the coffin of American automotive prestige. Modern Cadillac has learned from the Northstar disaster. The Blackwing V8, their latest high-performance engine, is overbuilt to the point of absurdity. The block can handle 1,000 horsepower. The head bolts are massive. The cooling system is designed for track use. It's as if they're still apologizing for the Northstar's sins, and perhaps they should be. The Northstar's story is ultimately about hubris. General Motors tried to leapfrog decades of evolution with one revolutionary design. They ignored fundamental engineering principles in pursuit of impressive specifications. They chose aluminum threads over steel inserts to save a few pounds. They specified head bolts that were marginal at best. They marketed an emergency cooling mode as a feature rather than fixing the cooling system reliability. Every decision prioritized the brochure over the owner experience. Think about the engineers who designed the Northstar. They were brilliant people who created genuinely innovative solutions. The variable valve timing system was years ahead of the competition. The lost foam casting process produced incredibly precise components. The engine management system was sophisticated enough to detect misfires and adjust accordingly. But all that brilliance was undermined by a few critical oversights that turned innovation into catastrophe. The final insult was the Northstar's longevity in production. GM kept building these engines for 19 years, long after the problems were well documented. Every year, thousands more customers bought Cadillacs with ticking time bombs under the hood. Every year, GM insisted the problems were fixed in the latest version. Every year, the forums filled with new horror stories. In the end, the Northstar V8 stands as the most hated American engine of all time, not because it was poorly engineered, but because it was brilliantly engineered in all the wrong ways. It represents the intersection of ambition and negligence, innovation and ignorance, potential and disappointment. It could run without coolant, but couldn't keep its heads attached. It could rev to 6,500 RPM, but consumed oil like a two-stroke. It made Cadillac competitive on paper, but destroyed the brand in driveways across America. The Northstar proved that specifications don't matter if the engine destroys itself. That technology means nothing without reliability, that you can't out-engineer poor decision-making. It remains a permanent reminder that in automotive engineering, boring reliability beats exciting fragility every single time. The most advanced production V8 in the world became the most avoided. The engine that was supposed to save Cadillac nearly killed it. What's your Northstar horror story? Have you owned one of these beautiful disasters? Or did you dodge this particular bullet? Let me know in the comments below. And if you enjoyed this deep dive into engineering infamy, hit that subscribe button for more stories of automotive ambition gone wrong. Until next time, remember, sometimes the brightest star burns out the fastest.